Let's take a look at how a simple blockchain simulation could look like. We first need an instance of our runtime. Then we define three users, Alice, Bob, and Charlie. We set the genesis state. In our example, we transfer to Alice 100 token, and we then start our block simulation. We increment the block number and validate that the block number really got incremented through this assert equal. Then we move on to the first transaction we're gonna send. We increment the nonce of Alice and then transfer from her to Bob 30 tokens and map the error if an error occurs. And now this is very important that you want to use here map error. If you would panic, for example, a user would control when to crash your blockchain. So someone could on purpose transfer more tokens than they have, and this would crash your blockchain. So if it's user controlled, you don't want to panic. You want to somehow silently swallow it and do something, but not panic. In our case, because it's a simplified version, we just map it and print the error. Then we move on to the second transaction. Here we increment the nonce for Alice as well, because she's transferring now to Charlie 20 tokens. And again, map error and print ln. And overall, this mimics the behavior of a real blockchain logic, just in a simplified way. We want to gracefully handle non-critical errors, because this makes our runtime design more resilient. And the genesis state is always present and required in every blockchain as well, either through a chain spec or a config file. That depends on the blockchain.